Alright, these are your notes for section 5.6, part 2 on fractions with radicals in them. Now, you've done something that you may think is similar to this before when we rationalized the denominator. This is not rationalizing the denominator, it's just a whole different idea, okay? We're still just changing the way the problem looks, but it is not rationalizing the denominator. Now, fractions with radicals, I want to show you the difference. In this first one, this is an example where we would rationalize. Okay, I have a fraction, it is completely underneath a radical, and I could split that up so that I have one radical in the top and one radical in the bottom. I have one thing in the numerator, one thing in the denominator. That's a case where we would rationalize. This is the case we're going to look at today. Notice we have radicals in the numerator and denominator, just like we did in the other one when we split it up. However, it's not just by itself in the numerator and the denominator. We have a whole expression. Our numerator here is 1 minus square root of 3. There are two unlike terms there. Okay? So it's the same thing that I was talking about when we were looking at foiling. It's not just strictly multiplying them together. It's not just one thing in the numerator. Okay? Pay attention to that, because it's a mistake that catches a lot of people. A lot of people will think that they can rationalize this, and you can't. You have to use what we're going to talk about in this video. Okay? So we got 3 bullet points here. First bullet point is do not rationalize. Okay? It is not just one thing in the denominator. You have two unlike terms in the denominator, so you cannot rationalize it. Do not rationalize these. The second bullet point, remember we said that there's no radicals in the denominator when we were talking about rationalizing. That rule still applies. So our goal is to get rid of the radicals in the denominator. And to do that, we're going to use this idea of a conjugate. Okay? Now what a conjugate is it's the same numbers with the sign changed. So if this were my denominator, 5 plus the square root of 3, my conjugate would be 5 minus the square root of 3. All we do is change that sign in the middle. Here's another example. If my conjugate were 1 plus square root of 2, it would become 1 minus the square root of 2. That's my conjugate. All we do is change the sign in the middle. Okay? That's what a conjugate is. And we're going to use that idea to solve these problems. We're going to do one example. I'm going to walk you through it. You should know how to do most of the steps at this point. The only new idea is going to be what you multiply by, that idea of a conjugate, because everything else is foiling, simplifying, combining like terms, stuff that you've already seen that we've already talked about. So the only new idea in this section is that we're going to use this conjugate. Alright, we're going to use that same example we did above. 1 minus the square root of 3 over 5 plus the square root of 3. Now, another thing that happens is a lot of people will think they can just cancel the 3's, the square roots out. That doesn't happen either. You cannot do that. You can only cancel when you're multiplying, and we're not here. We're subtracting in the top, we're adding in the bottom. It's not multiplication. They do not cancel. So we're going to use this idea of a conjugate. And we're going to pick ourselves a well-chosen one. Now it's called a well-chosen one because it's the same on the numerator as is in the denominator. It cancels itself out. And it's just going to be that conjugate. So 5 minus the square root of 3 and 5 minus the square root of 3. Now, again, that's a well-chosen one because it's the same in the numerator as it is in the denominator. Anything over itself reduces to 1, so that's really just the number 1. Okay? We're going to multiply these together. And to do that, we're going to FOIL them. The top gets FOILed. It's 1 minus the square root of 3 times 5 minus the square root of 3. And then in our denominator, we have 5 plus the square root of 3 times 5 minus the square root of 3. Okay? So we're going to FOIL these. I'm going to spread this out a little bit so that we have some more room. I'm going to write the numerator over here. And we're going to FOIL it, and then we'll FOIL the denominator. Okay, let's FOIL the numerator first. First, 1 times 5 is 5. Outside, 1 times the negative square root 3 is negative square root 3. Inside, negative root 3 times 5 would be negative 5 root 3, because the 5 is outside and the 3 is underneath. It's the radicand, so they just get put together. And then the last one, negative root 3 times negative root 3, well, two negatives make a positive, and 3 times 3 is 9. Okay? Let's simplify this. That's going to simplify to 3, because the square root of 9 is 3. So now we have 5 minus root 3 minus 5 root 3 plus 3. 5 plus 3 is 8, minus root 3 and 5 root 3. There's really a 1 here. Okay? Now I have 1 root 3 and a 5 root 3. I take them together and I get negative 6 root 3s. It's like being $1 in the hole and I gave away 5 more. I am $6 in the hole. Okay? So there's my numerator. My denominator, I'm going to FOIL it. 5 times 5 is 25. 5 times negative root 3 is negative 5 root 3. 5 times a positive root 3 is plus 5 root 3. And then we have positive root 3 times negative root 3 would be negative square root 9. The middle two terms cancel each other out, because one's negative, one's positive. They're identical to each other. And that final term becomes minus 3. So we are left with 25 minus 3. And 25 minus 3 is 22. So our answer to this problem is 8 minus 6 root 3 over 22. Now, if you stop there, you are almost finished. The reason you're almost finished is because there's a greatest common factor in this problem. There's a number that goes into 8, negative 6, and 2. It goes into all of those. Sometimes you'll have a greatest common factor and sometimes you won't. In this case, we do, okay? We need a number that goes into 8, negative 6, and 22, and that number is 2. Okay, so 2 is our GCF. 2 goes into 8 4 times. 2 goes into negative 6 minus 3. That 2 does not go into the radical, okay? It only goes into the number out in front. And then 2 goes into 22 11 times. So there's the answer to the problem. 4 minus 3 root 3 divided by 11. Notice we have no more radical in the denominator. It canceled itself out by using that conjugate, okay? That's what we do if there is an expression in the denominator with a radical. We don't rationalize it. We use that idea of a conjugate, and we multiply by a well-chosen one, FOIL, simplify, and we end up getting a fraction where there's no more radical in the denominator. If you have questions, go back and rewatch that example. Otherwise, bring them to class next time. And those are your notes for section 5.6, part 2 on fractions with radicals in